This is Colin. He's an iRobot Roomba device, model 520, and he's been doing a fantastic job keeping my flat clean for the past 2 to 3 years. What I'm going to do today is hopefully quite a simple upgrade. I'm going to dismantle him, clean him, and then add Wi-Fi connectivity. There is a data connection port under here which is designed for kind of developers and hackers to interface with, and that will expose a wide variety of sensor data and hopefully even allow me to control Colin remotely. The first step, I'm going to head over to the workshop, dismantle him, properly clean him, and then come back and work on the electronics. First thing I'm going to do is pop the top off of this. It's not necessary for disassembly, or at least not the first step anyway, but it allows you to see the data connection. Now this top facade just clips on in a few different places. You've just got to carefully work around and release it. I've removed this once or twice before just to have a quick look, and it's always been annoyingly fiddly to do so, certainly without damaging things. There we go. So on the side here is the data connection. They've gone for a custom DIN connection. It's a bit annoying, but it probably makes sense from their point of view because it's not a standard connection of any kind. It carries serial data, a status signal of some kind. I think it wakes it from sleep, although I can't remember at the moment, and power pins. And so that should be all we need to get access to. I'm not going to plug into this directly because I don't want to increase the overall height. I want it to be able to pass underneath sofas and low-lying objects. So I'm going to tap into the port from within the board itself, or at least hopefully. First of all, I'm going to flip it up over and start disassembling it from underneath. Okay, so I'm going to remove this bit first. This is the little brush which kicks loose bits of dirt in the line of the hoover. Okay, keep me safe. This filter mechanism, I seem to remember, also comes out. Yep. At least in part. To one side. That. There's a lot of Christmas tree left inside. And also extract the bay at the same time. This is the bit that collects all the waste. It's got a two-part mechanism. The kind of larger particulate matter gets kind of kicked into here, and there's a hoover or kind of fan in here which then sucks dirt or dust through this very kind of fine grill here that then gathers in the filter in here. I'm just going to give these bits a quick hoover. Okay, giving it a rough hoover, well, I'm sure there'll be more inside. The next step is to remove this base cover here. Okay, this bit is clearly meant to be user serviced. The panel kind of slips straight off, the screws kind of are held within the mounting so you don't lose them. And obviously you've got the battery pack right in here. This comes straight out. It's a single self-contained, I believe it was a lithium pack, no, nickel metal hydride. Presumably, obviously over life it will degrade and need to change. I haven't noticed any kind of degrading of this over time. I'm sure there has been some, but certainly for my use it hasn't caused a problem. It's one of the other benefits of getting access to this data port apparently provides some kind of power monitoring management, so you can see what the battery level is. So it could be interesting to graph over time to see how it's dropping and whether it does reach low levels before the end of its regular cleaning cycle. Okay, right, I'm just going to give it another quick hoover and we're going to carry on disassembling. The next step, according to the instructions, is to flip it over and remove the top cover. Obviously with that extra weight to the battery, it's not sitting down on the sprung motors. Okay, so I've managed to get that. The bumper needs to come off first by the looks of it. and that is hooked onto the front with a number of lugs. You need to very carefully prise these out, and this whole section seems to free up. Got the wire attached in there. That is for the location system. Let's see if we can continue to get the top cover off there. There we go. Okay, carefully free this wiring here. There we go. Top cover can move out the way. Let's put the main circuit board under here. Yeah, the bumper here is plugged in. I can remove that. Put that away. Right, that's the bulk of it disassembled. And this is the connector we're interested in. And it appears to have a lot of unpopulated pads on the circuit board. Okay, if on this pad here we've got a lot of unpopulated what appear to be LED mounts. This is a bottom of the range, kind of bottom model unit, so it looks like there's a lot of functionality hasn't been implemented for the standard parts. See, on here there's a light behind this which shines through if it detects a dirty area, and behind here there are presumably status lights of some kind. I've never noticed any, but if you look for the alignment, that comes through to this area here. And there are, right in here, we've got two LEDs which have been populated, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 LEDs which haven't. So presumably if you've got a better unit, you're going to get a lot of extra status information. So I'm going to try and free up this board and see what is on the other side. What else is missing from this model? Attached to the boards here, we've got a series of connectors coming in. This is the motor control for the Hoover mechanism that's attached to the waste bin, and when that slots in, that allows it to activate that. That leaves us with a 3-pin connection down here, which is going to the charging point by the looks of it. That's, the unit is meant to be charged on a charging station. When it rolls in, it makes contact with these two terminals here. But it does have a backup charging port for the power supply that actually feeds the charging station, which is quite nice. And so that's looks like a 3-pin, I think that's 3-pin connection, which must override the other charging mechanism. That's what comes through to there. That just leaves this other 2-pin connection, which is probably one of the sensors in the back. So obviously there are still 2 motors in here for the main drive motors. Vast array of sensors around the front and the front bumper as well. Apparently it's got kind of drop sensors and other sensors in there. So yeah, some of the additional sensors around the sides. And there. And these will presumably detect drops. So if it kind of tries to go down a flight of stairs, it will stop and return. There's also the dirt detect system, which is not something I've ever really figured out. Somehow it detects an area of ground which is dirtier than normal and stops and does an extra spin in there. I'm going to continue to try and remove this board. Just right in the front here, got 2 additional sensors. Some kind of range distance sensor. Now that makes sense. So as it begins to approach an obstacle, it slows down, so it doesn't bump into it too much. That will be either a simple kind of something's too close, or a more detailed kind of range sensor. Bring it in. I've got the switches here for the 2 side bumpers. That maybe some kind of shock absorbing impact. It seems to be rubberized there. We've got a lot more LEDs along the sides, which means there might be something else. There's probably something else going on in here. The sensor ring here seems to just slide out. Okay, we've got a few more bundles of wires in here. Heading down to the sensors on the front caster, which detect rotation. Gives an idea of how fast it's moving, or if it's moving at all. Heavier duty wire coming down here. That must be for the charging pads. Still no sign of any motor wires. There's nothing particularly heavy duty left in here. Just can see what that one... Oh, that's for the speaker in there. And so it's got a series of recordings inside and beeps and tones, and that connects through from that one there. It's the motor wires. Must come down from here. It's quite possible they've got an onboard motor controller which allows for that. I'm trying to be careful because I need to make sure it all goes back in one piece. Okay, I'm going to have another rummage and see if I can find anything else. I've just removed the connectors from the rear of the board and flipped it out. Some few interesting observations in here. This board itself was a little tricky to remove because it plugs into connectors within the chassis. It's got 3 of these connectors here, which push onto kind of PCB edge connections by the looks of it, and just mounted in the holes. It's also got 2 sprung connections here, which again make contact with something on the board down here. I'm not sure what they're for yet, but they're labelled MEC 14. MEC 15, so something maintenance mechanical kind of thing. The board is scattered with hundreds of these test points, so clearly it went through some pretty serious kind of testing regime just to check everything was kind of produced suitably. So yeah, there's an awful lot of stuff that's unpopulated in here as well. Got these 3 points here, which again are connected to switches, so quite possibly on a better model I would have had a, that sits in there, yes, so yeah, there'll be a series of switches on different model devices, and yeah, these pads on these are exactly the same as this one here. And so we've still got the test connection here. Again, that will hopefully be easy enough to remove. It's just a through-hole connector, and we can wire straight into that. And because that provides access to so much, there is really no need to go any further and tap into anything else, but it's interesting to see what could have been if this was a little bit more fancy. The heavy duty sprung connection here that runs through to the main base, that is quite possibly going to be for this motor here, the little one that kind of kicks out dirt and dust. The motors themselves have got stall sensors in, presumably just current sensors of some kind, and they are probably going to be controlled through these kind of PCB edge connections which connect down. There aren't a huge number of connectors on them. It has 12 pins on each of them, so it'll be kind of signal connections along with data or sensor data back, and most likely they are further down in the board, more kind of integrated control units for the motors. There's still a lot of stuff going on the front and here. Yeah, there really doesn't appear to be anything connecting to this rather bizarre piece, so yeah, presumably it is just shock absorbing. It's too strong to require it to move against that when charging to know it's docked, so there'll be no other reason for that other than shock absorbing kind of fast impact so it doesn't detect. Now this sensor bar here just appears to be LEDs of some kind. Can't see any sensors in there unless presumably they could be sensors, but they're... Ah, yes. I've got a variety around here, so by the looks of it, they're either transmitters and receivers, or all receivers looking at different types of light. So there's some kind of clear and some with a much darker package. The better models, or actually probably this model as well, you can get a sensor gates, which were smaller units, would emit an IR beam, so you could use it to block off rooms or areas that you didn't want it to travel. So presumably as it comes along, it would kind of see when the beam would hit one of these sensors, it would know it can't go any further and back off. And it's possible they are all for that. Okay, I'm going to go ahead and reassemble this now. I think there's nothing much else to get out of here, or to learn from the way it works. The only other piece to note here is this sensor, which is in the front bumper. This is used to locate the homing beacon. It's got a rather interesting little kind of optical arrangement in there. It's a 3-pin connection in there, and it picks up and, I believe, kind of locates the front, or locates and homes in on the charging station. Although it does seem hard to believe it's got, it can kind of locate where it is. It just seems to pick up from any direction. Maybe in fact that is some other kind of identification. Okay, back together it goes. See if I can power it up just to make sure it is still functioning. It's a good sound. The power button is the middle connection. There we go, and
move Roomba to a new location, then press clean to restart.
these will probably be the sensors on the wheels which detect that it's not sat down. It's fairly stable in its current state. I'm going to transport it home like this. First of all, I am going to rig up a method to test. So I'm just forcing the battery in underneath with a screwdriver, and I think it should be good to check. There we go, it's all functioning. Right, I'm back at home, and I've started work on the board, getting that connected up. I had a go removing the original connector, the mini-DIN connector, but unfortunately I didn't have much luck with that. I don't really have the equipment to properly desolder that. So rather than trying to remove it and butcher the board, I located the test pins that corresponded to the connectors for the pins. They're 5 little kind of test points just around the edge. I was able to solder a ribbon cable directly to it. And this will kind of then run out and tuck underneath the board as it fits in place. I'm about to fit this back in. I can then connect this up to some breadboard and take a look. Just briefly, while I was kind of working through the board, I spotted another kind of unpopulated area which I didn't notice before. We've got the 4 digits for a 7-segment display just sat in there. That would be the choosing what program you want it to run, what sequence, or how long you want it to wait before it starts, or anything like that really. The buttons up there would have controlled it. I fitted the board back in place, and I've got the little ribbon cable running out the front here. And what I'm going to do is connect this up to an electric imp. I've used these on a few times before in different projects. They're kind of really nice little boards, great way to get online. It's a kind of SD card form factor, which is slightly unusual, but it's got an integrated wireless adapter, Wi-Fi adapter, and it runs on the Electric Imp's online development platform. So it uses an online IDE to communicate, and you kind of program it and control it online on that system. Yeah, because they're really simple, easy to use, and I had a couple of these development boards lying around, and I'm going to fit one of these in here. I found a little compartment on the side. This is where the DC jack used to go. I never used that, and I'm not really planning on using it, so I've removed it. And it just about fits. I tried to hack away at it a little bit, but I'm hoping the cover will kind of still sit down and leave a little bit of space. I'm going to wire this directly in. The data connection itself coming out of here, we've got raw battery power, which I think is about 14-15 volts, along with 3 data connections rated at 5 volts. Now this board itself is 3.3 volt power rails. The breakout board has got a little voltage regulator. It's capable of running or accepting a battery voltage of up to about 16 volts, so hopefully it should do the job and I should be able to hook it up without any additional parts. Also, ideally I do need to be using a 3.3 volt signals, but I've used 5 volt signals before and it's worked, so I'm going to give it a go as is. So I'm just going to wire this up now, fit it in and power it up and see if I can kind of get some messages out of it. It's now the second evening working on this project. I spent quite some time last night working on the software interface and trying to get it to the Electric Imp web interface and getting that to talk to the Roomba. In the end it worked, but there were some complications in the way. I point out it's quite a straightforward setup I went for with this, just reading serial data and the kind of device wake-up signal, which you can pulse low for a couple of milliseconds and it will bring the Roomba out of standby, ready to receive serial data. The datasheet mentioned a particular baud rate for the serial connection, and that looked promising to start with, as it did seem to stream out a lot of status data. It also responded to the odd random command, but it was very intermittent and it didn't work as expected. In the end, I tried cycling through various different baud rates and I finally hit on one which worked. And all the stuff I'd been trying worked perfectly. Serial data going in and out, so I can send commands to get it to turn on the light, make a noise, start moving, and reading off all the sensor data as well. And yeah, and that is kind of where I'm at so far. I'm going to now carry on with this. Now that I know this works, I'm going to finish off mounting the circuit board within the chassis and get that connected up. The original plan was to fit the Electric Imp breakout board within this compartment here. This compartment held the charging port. As I said, this wasn't something I was going to use, so I decided to remove it. When I went to charge Colin last night, I discovered that it wouldn't charge at all on the pads underneath. So it looks like rather than switching this mode, this connection in using this extra line here, by removing this, it defaults to this kind of input pin and doesn't allow the other pads to charge. So this will need to be kind of modified, or I need to kind of work out how it's wired and jump it across to force the charging connections underneath to carry on working. The other thing I've kind of came across when I was having a go at mounting was that the top kind of casing that fits in has a kind of a locking pin which moves inside this space here. That means that there is no room for the circuit board in there. So I decided I'm going to put this back and leave the charging port in place, as there's no point removing it. And I'm going to mount the top of the new circuit board in the top, I think roughly at this point here. So the top section here was meant to contain an additional display and other buttons, as you can see here. So there's a little bit of free space. I've had a brief play a little earlier and I believe it should be possible to kind of tuck that into there. So what I'm going to do now is to get that mounted, get these pieces put back together and reassemble. Well, it looks like I may have just broken it. I left the battery kind of fitted in last night for testing, And this board here, which is obviously hooked up to the battery power supply, kind of brushed across the board. I'm not quite sure what it touched at the moment, but this chip here is kind of burnt up by the looks of it, which is really, really annoying. I'm going to dig into this and find out exactly what has gone wrong and what I can do to repair it. I've just quickly done a test and checked the motors, and it appears to power up, so I haven't completely destroyed it. Same startup beep, goes on, comes out of standby, and if I hold the motors in place, it will start moving. I'm going to try and connect up some of the other motors and see if it's one of those that has gone. Maybe it's part of the charging circuit that's gone. Okay, I've had to go charging this, and it doesn't charge anymore. I get a lot of red flashing lights and an audible message saying charging error 3. The help articles for this talk about resetting the software, but I think in this case that's not going to help. The part in question, or at least this part, is a MOSFET, and presumably, I can't quite see the part number anymore because it's burnt off, but presumably that is the same. I can't see any other obvious damage on the board, so I'm hoping it is just that's blown. If that is the case, then with any luck I can switch it out with a replacement part. Also, it does turn this what was meant to be a one-day project into something a little bit longer, but at least it looks like it can be repaired. For the final mounting option, I've chosen to mount the board here. It's far from ideal, but given the options available in this fairly tightly packed case, I think it's probably the best solution, at least for now. The ribbon cable just kind of runs around in this slightly unprofessional manner, but everything is perfectly covered by this front plate. Once that goes in, you don't really see anything apart from the front edge of the electric imp sticking out. The buttons are still kind of accessible. The top kind of plastic case goes on. This doesn't get in the way, and yeah, it kind of works well. This, I have kind of just stuck it to this piece of plastic here, just using sticky pads. It's like I say, very crude, but at least in this case it's effective. It does mean that when it comes to repairing the charging circuit, I can remove this mounting point here. The whole plastic piece will then kind of come away and get out of the way so I can get in. I think also before I finally pack it away, I will attach kind of a little bit more insulation under here, just in case a sharp kind of connection pokes through and shorts things out again. I've been doing some work on this, fitting the electronics and tidying things up a little bit, and I've decided to make one small modification. This was initially something I dismissed because I didn't think it would be necessary, but I did overlook something rather silly. The power supply for this comes directly from the battery feed, which is fine because it's within the limits of the small regulator on the breakout board, but when it's docked and charging, it's going to get the full charging voltage, which is a lot higher, and so that is potentially going to damage things. And so what I fitted here is a small 5-volt voltage regulator. It's quite a nice one. It's a switch mode regulator, but in a kind of more traditional package. I've just split into the kind of power cables, fed into there and back out. So a little bit messy, but it should do the job. And I've also taken the opportunity to break out a switch connection as well. At the moment there will be no way to turn this off, and when it is packaged up, you can't get at it to restart it or to power it down. So I'm going to mount a switch, a toggle switch on the end of this, possibly in the kind of switch compartment or the kind of power charging compartment, possibly even go back to removing that connector and hiding the switch in there. This way, if the imp needs to be rebooted, because the software locks up or any reason like that, it doesn't have to be dismantled. I can just flick the switch. I think I've now finished with the inside of this for mounting the electronics. What I've done is mounted the switch in the charging connector. You can just about see the base of the toggle switch in there. I can just then reach in and turn that off if needed. It's not something that will be accessed very often, but at least this way I can at least do something. The original charging connector that was in there, I've decided to leave it in place. I'm basically tucking it into the hole, just to kind of keep it out there. If I wanted to remove it entirely, I'd need to bypass this connector here, connecting the black terminal straight through to the brown terminal, and that would kind of switch to base charging permanently. Because the space is there, I decided not to bother. It doesn't cause any problems, and I've used a little bit of hot glue to tie everything down. I've also had to make a slight modification to the shell. There's a kind of a mounting pin which came down on top of the charging port, so that was going to get in the way of the switch, so I've kind of trimmed that back a little bit. And so now the top piece fits together quite nicely. And its switch again is hidden in there if you'd ever need it. The top panel still fits on fairly flush, or properly flush, so that will mount on nicely. And this is ready to go back together now. The only thing it's waiting on is a replacement MOSFET for the charging circuit. I've got several of those on order, so hopefully I can replace those next night and have this fully up and running again. Right, we're into day 3 now of this project, but things are looking positive. The delivery arrived today, got some new MOSFETs through. Unfortunately, £5 for the MOSFETs and £5 for delivery, so it's not too bad, but a really annoying expense to have to make. I switched over the MOSFET and it is now functioning again. It powers up, it seems to charge, no errors, and I'm now going to carry on with this. Everything's in place now. I'm going to fit it back together and hopefully get it moving and make sure it still works. The software side of things has been pretty successful. I've been continuing to work on that. I've got an API kind of endpoint up and running, which is now fetching data. There's a kind of a worker background process which runs on the electric imp, which wakes up at the moment every 30 minutes, reads off the sensor data, uploads it, and then goes to sleep. I've got a number of these bits of data being passed out to Excitedly, and so I've been plotting kind of various different graphs today of the battery voltage, the temperature, current draw, kind of thing. It's rather disconcerting most of the day seeing the battery level slowly drop and not knowing if it's going to be possible to recover, but it is now functioning and it should be pretty easy to turn that into something quite interesting. Before I pack everything away, I did make one final change. When I was working on the software today, I came across a few issues. Ideally, when this is operating, I'd like to get sensor data flowing in at a pretty high rate. But when it's not in use and turned off and standby, I don't need anything that often. Every couple of hours, once or twice a day even, would be more than fine for that. And at the moment, previously, there was no real way of knowing what state it was in. And so what I've done is tapped into a signal line which is used on the edge of the board down here for the amplifier. It's a signal which pulls or turns the amplifier off if the Roomba is not in use. And so what I've done is put a very kind of crude little voltage divider and feeding that into pin 1 of the electric imp. Pin 1 can be used to trigger it, bring it out of a deep sleep mode. And so when it starts up, it takes note of the previous state of Colin. If it's turned off, it turns him on, reads the sensor data, turns him off, and then goes to sleep for a couple of hours. If he was on when it kind of ran through its main loop, it reads the sensor data, goes to sleep for a couple of minutes, wakes up, doesn't check again. It doesn't try and turn him on or off or get in the way. Hopefully this will give me the best of both worlds, so kind of hopefully real-time sensor data when it's in use, and kind of nice background data when it's not in use. This screen here shows the data that is being piped out to Xively. I've got various different channels set up. The battery capacity here in percent. This is a little bit iffy because it's quite hard to calculate battery capacity, and I think when you reset it when the power disconnects from it, it defaults to 100%. So this is when I'd removed the battery and kind of put it back in again. After it had been moving around for a little bit, it clearly does kind of calculations on the fly to work out roughly where it should be, and it corrected itself here to down to around about 40%. The other kind of graphs I've got showing here are the current draw. This is a kind of positive and negative, showing at the moment we've got a positive figure here, and this is because it's charging, and so it's charging at quite a high rate. And also, and here you've got a few little marks where I had it kind of out and about and testing. Got down to about almost 1.5 amps in places. The temperature being logged internally is available. This is simply just to detect kind of over temperature. I'm not quite sure where the sensor is, but it's quite an interesting indicator of just room temperature, assuming it isn't kind of being affected by the charging. The final one here is the battery voltage. Again, during the day, we're around about 14 volts, kind of dipping down a little bit. And again, when it's in motion, when it's actually being used, the draw of battery voltage here drops, as you'd expect. And now it's been on to charge, it's starting to recover a little bit. In addition to piping these bits of data out, I've also got a JSON endpoint I've set up. This is basically every bit of sensor data available, and it should be pretty easy for me to kind of consume and use. There's some interesting kind of sensors in here. There's a few of these I don't believe are used. There's a front drop sensor, which I don't think it has. A wheel drop caster. The charge mode is kind of reflects the status of charges. It hasn't been as useful as I was expecting. I was hoping it might show an error condition when I was trying to charge it last night with the broken part, but it didn't. It just showed its kind of standard mode during the day. Possibly that might get more interesting as it starts to fully charge and then trickle charge. The other interesting thing I noticed is the virtual wall. This is the other sensor products they provide to stop it moving around in unwanted places. When it was attempting to dock earlier, this kept triggering to true. It was also having a lot of trouble docking. It seemed to kind of get close and then move away, almost as if it was detecting the docking port as a virtual wall, but not a charging station. So it got close, thought, oh no, I shouldn't be here, and backed off again. So that's something I'm going to have to watch. It's possible one of the sensors on the front has been damaged or it's not quite right. I finally reached the end of this project. It was meant to be a quick one evening modification, but in the end it kind of spread across 3 days and included me repairing a mistake of mine. At least it was possible to repair it. Colin is now upgraded, he's connected to the internet and he's streaming data, and I've got the ability to kind of view that, modify the code remotely and even turn him on and off